Coding benchmarks typically use binary rewards. The test suite passes or it fails. There's no partial credit. Now consider a hard problem. The model samples 8 trajectories. All 8 fail. Rewards: 0, 0, 0, 0, 0, 0, 0, 0. Mean 0. Standard deviation 0. Division by 0. The advantage is undefined. In practice, implementations add a small epsilon to the denominator to avoid the crash. But the advantage is effectively 0 for every token in every trajectory. The gradient contribution is negligible. The model learns nothing. The hours of compute that generated those 8 trajectories produced no training signal whatsoever. The same thing happens when all trajectories succeed. Rewards: 1, 1, 1, 1, 1, 1, 1, 1. Mean 1, standard deviation 0, same result, 0 gradient, no learning. This isn't rare. Hard problems produce all fail groups routinely. That's what makes them hard. Easy problems produce all pass groups routinely. That's what makes them easy. GRPO generates useful gradients only in the narrow band, where problems are neither too hard nor too easy for the current model. The problems that need the most learning, the ones the model barely handles or barely misses, are exactly the ones most likely to produce zero-signal groups. You could increase group size to make mixed outcomes more likely, but that multiplies the generation cost, which was already the first failure mode. The 4 failure modes don't just coexist, they reinforce each other. GLM5 2 returns to critic-based PPO. To understand why this solves the 4 failures, you need to understand what a critic actually does. A critic is a second neural network, the value network, that runs alongside the policy model. The policy model generates tokens. The critic evaluates states. At every position in the sequence, the critic looks at the full context and outputs a single number, the value estimate. From this state, how good do I expect the final outcome to be? The critic isn't generating tokens, it's predicting the future. Early in training, its predictions are bad. It might estimate 0, 5 everywhere. But as training progresses, the critic learns the landscape. It learns that certain states clean code structure, correct diagnostic reasoning, productive tool use tend to lead to success. Other states wrong assumptions, broken logic, dead-end exploration, tend to lead to failure. The advantage for any specific token is the difference between the critic's estimate after that token and the critic's estimate before it. If the critic estimated 0, 3 before the token and 0, 7 after, the advantage is plus 0, 4.